All right, so now we're going to talk a little bit about weird graphs because probably on your test you will have like one weird graph, and the tendency is to freak out a little bit. The first most important thing is the more you take practice sections and the more you do ACT science stuff, the more graphs you'll see, and the less chance there will be that you'll see something truly that you've never seen before. You just start to see them all and get used to different types of things. And then, even on top of that, if you do see something that's a little bit unfamiliar, you will have seen something close enough so that it won't be like, whoa, what am I looking at? So that's the most important thing. But let's look at some of the unusual features that you can see in some weird graphs. So, first of all, we have a logarithmic graph. And what you see here on the y-axis is it goes from 0.1 to 1 to 10 to 100 to 1,000, etc. So it's being multiplied by 10 every time. So this is not linear. This is exponential or logarithmic, however you want to call it. And you have the same thing happening on the x-axis, okay? And in a little bit of a weirder way, 0.1 to 0.3 to 1 to 3 to 10. So a little strange. This is the asteroid diameter, and this is the average time elapsed between consecutive asteroid impacts. And the reason they do it that way is because, like, it's really hard to start from point one and go to 100 million if you're skipping by tens. You know, you can't do that on a graph. So this allows them to get a lot of information on one graph. Okay. You just have to be careful about, getting the right data and not kind of assuming that it's a graph like a more familiar type of thing. Let's look at another one, a phase plot. Okay. So here, like in this whole region, right? So it's not the lines that matter. The lines are like the boundary areas, or set the boundaries for the areas, and it's the areas that matter. So in this region, any percent Durine, but only up to 42 degrees Celsius, both Durine and biphenyl will be solids. And then like if you're at 20%, but then you're at 50 degrees, then it would be like represented by like this dot. If it's in there, that means that biphenyl is a solid, and if it's 50 degrees and 70% Durine, then Durine is a solid. And in this whole area, everything is a liquid. Okay. So, if you're like starting at 60 degrees and you're going across, then biphenyl will be solid up to here, and then biphenyl will be a liquid here, and then then Durine becomes a solid here. So you have to just kind of pay attention to the area of what's going on. All right. The last graph is this vertical graph. This one I remember, it's from an old test. It's super weird. But again, like you want to like get the story. Okay, so you have intensity in decibels and frequency, and this is all about sound. So if you looked at a specific point, let's say if the frequency is 1 times, let's do 1 times 10 to the 1, so that's 10, then here, basically it's below the threshold of hearing. So this is not something you would hear no matter what the intensity. Like it can go up to 240 decibels, you're not going to hear it. If it gets to 2 times 10 to the second here, then you will not hear it if the intensity is like below 20 in this area. And then once the intensity hits 20, you hit the threshold of hearing. And then so if the intensity goes up there, then this is a sound that you hear at this frequency and this intensity. And then at this point is the threshold of pain, and it actually becomes painful once it's at 120 decibels. Okay? So it seems like, there's this little bulge here of threshold of pain. So at this frequency, you can get a little louder and it doesn't hurt. And then, again, above a frequency of like 20,000 or something like that, you don't hear it anymore. So too high frequency or too low frequency. And so that's what's going on here. And then there's this little bit about in air and in water. So I guess the lines that represent intensity are somewhat different. It's a little strange. I don't know what S is. I don't remember. Um, but basically, you just have to go slowly here and look at all the different parts, and they're not going to ask you crazy questions. Like, the hardest thing about this is that the chart is hard, so they're not going to make you crazy in terms of asking you super hard questions. Mostly they're just going to see, hey, can you figure out a weird chart? And if you can, and you can, because it's really just like reading any other chart, then you're really going to be totally fine.